Chapter 13, Open Channel Flow. All right, class, today we are going to imagine something very simple, watching rainwater flowing along the side of a road or playing in a small river. Whenever we see water flowing in channels where it has a free surface open to air, like rivers, canals, or even drains, we call it open channel flow. It's different from water inside a closed pipe because here we can see the water surface, and gravity helps to pull the water along. Just like when you slide down a playground slide, water flows downhill because of gravity. Now, every time water moves, it behaves in different ways. If it flows calmly without changing much with time, we call it steady flow. If the flow depth stays the same everywhere, we call it uniform flow, like a quiet river moving gently. But when the water gets deeper or shallower as it moves along, like when a river goes over rocks or under a bridge, it's called varied flow. Sometimes the water changes a lot over a short distance, and we call this rapidly varied flow, like when water spills over a dam. Sometimes the change is slow and smooth, called gradually varied flow. Water can flow smoothly like syrup, called laminar, but most of the time in rivers it moves wildly and swirly, called turbulent flow, especially because water has low stickiness and channels are rough. We use something called the Reynolds number to guess whether it's smooth or turbulent. And usually in rivers, it's always turbulent because of high speed and depth. We also have a magic number called the Froude number. This number tells us how fast water flows compared to how fast waves move in water. If the Froude number is less than 1, water flows gently and waves can go upstream. This is called subcritical flow. When it's more than 1, water flows super fast and waves cannot go back upstream. This is called supercritical flow. When it's exactly 1, we call it critical flow. This helps engineers know where water flows calmly or where it might create sudden jumps and splashes. Speaking of jumps, have you ever seen water suddenly rise in height after falling from a tap or faucet? That sudden rise is called a hydraulic jump. It happens when super-fast water slows down quickly, and it makes the water level rise and mix a lot, losing energy. It's the same thing you see when you wash dishes, and the water spreads out and suddenly forms a ring. Then we have something called specific energy, which is just the height of water plus how much it moves fast. There's a point where the energy is the smallest, called the critical depth, and it helps us know if the water is flowing calmly or where it might create sudden jumps and splashes. To measure and control flow, we also have simple tools like sluice gates and weirs. These are like small dams or barriers where we can measure how much water flows just by measuring how high it flows over or under the gate. Finally, when engineers design canals or channels, we want to make sure we can carry enough water, but without making the channel too big or expensive. So we use simple math tricks like the Manning equation, which helps us predict how fast water flows based on how smooth or rough the channel is. If the channel is smooth like glass, water flows faster. If it's rough with grass or stones, it slows down. In the end, open channel flow is like playing with water outdoors, watching it flow gently, rush fast, jump suddenly, and spread in channels. By knowing these simple ideas, we can make sure rivers don't flood, canals bring water to farms, and drains keep roads dry. That's the fun of learning how water flows in open channels.